Alright, here's our first sample problem. And in this problem it says a box is moved in the closed path shown. How much work is done by gravity when the box is moved along the path A, B, and C? This one's a little bit confusing because they don't do a very good job of explaining this diagram, so I'm going to help you a little bit. The box actually starts right here and it moves along path A. So we start moving it and it goes all the way across until it gets to point B. So from this point here where the box is all the way over, we notice that the work done is 0. This floor is frictionless, so there's actually no work that's being done from left to right. Then what we will do is we'll go from B, and when the box is at B, so here's the box at B, it then travels along up this way, and this would be path B itself. Then we move the box along path C. So now we're at this point and the box is moved all the way over. So what we need to do is just figure out how much work is done by gravity when we move that box. So this one's actually a little bit easier than what it looks. We know the work done by gravity should be equal to the work that we did at A, and the work that we did at A is 0, plus the work we do along path B. So here's path B, and we notice that that is negative mgh because gravity is working against what we are trying to do. And then we move it across this way, and we notice that because there's no resistance, that third area of work, and gravity doesn't work really in that direction at all, is equal to 0. So when we're done, we end up with the work done by gravity for that first part should be equal to negative mgh, and that would be the answer for part A. And so there's your answer for part A. We're going to do this again, but we're going to look at it for how much work is done by gravity when the box is moved along the path A, then B, then C, then D, and then back to A again. So we're going to start the box in that same place that we started it before. We're going to put the box right here. It'll move all the way over. It'll then move up. It'll move over, and then it'll move back down again. And that's essentially what they mean by A, B, C, D, and then back to A. Those are the positions essentially that we're looking at. So it starts at A, goes to B, goes to C, goes to D, and then goes back to A. So let's actually solve this. The work done by gravity should be equal to the motion of it going along the path that it was starting at A and going to B. So that would be 0, plus then going through the next series of steps, that would be negative mgh because you're picking the box up, plus 0 because now there's no resistance as you move from right to left, plus, and then we have positive mgh because we put the box down, and notice that gravity does the work there, so it's positive. If you sum all this together, we do get 0, and so that goes to show you that when you move the box in a closed path all the way around the circle, you should end up with no work being done if you go by just the strict definition of work for this.